Hello everyone, my name is Joshua Nigel Haldar. I am a postdoctoral fellow in Professor Imyango's lab in Sangji University. Today I am going to present about the combined effect of TAO system and electrochemical process on liquid manure treatment. My study will go today as introduction, goal and objective, experimental procedure, findings and conclusion. So let's begin. We know South Korea produces a large number of pig manure every year. In particular, 2017, the produced pig manure was 54% of total manure production. So, to reduce the adverse effect of the produced large amount of pig manure, one or combination of few faster and safer treatment method needed to meet the demand. As we know, the TAO system is already established as a fast liquid manure treatment for soil manure. And in the other hand, the electrochemical or electrocoagulation process has been proven as a fast wastewater treatment method that has been used for years. So in this study, we used the electrocoagulation process and tested this process on the tau influent to find out the possibility of co-treatment of these two treatment process and check their combined effect. So this study was performed as we treat influent by tau system first, and then the tau effluent was treated by the electrocoagulation process. So why we do that? We were trying to find a way for environment friendly high quality organic fertilizer which could be easy to produce and instantly applicable. So let's talk about the electrocoagulation a little bit. So, and the parameter of the electrocoagulation are basically three: physical, the functional, and the electrode. So when DC current used for electrocoagulation, which is generally used, the current go through the electrode in the solution. These electrodes are immersed in the solution, and when current pass through these electrodes, the interchange of atom and ion occurs. And when this interchange of ion and atom occurs, the anodic how it occurs, let's see. The anodic metal that solute by the current supply, and it starts the separation of hydroxyl ion, hydrogen and oxygen, and this separation take place when the particle get destabilized by the supplied DC current. So this destabilized particle was captured by the hydroxyl ion, and they aggregate the flocculation and flotation, and some particle aggregate and get sedimentation. The main goal of this study was check the possibility of combined treatment of tau and electrocoagulation, and our objective was the testing the performance of electrocoagulation on tau influent and compare the efficiency of tau and electrocoagulation. So how we get our sample? We get our samples, we get our influence for tau treatment from the anaerobic digest and purified liquid manure. The anaerobic digested was collected from a biogas center, and the purified liquid manure was collected from a pig farm. And these two influent was mixed in 1:9 ratio. And after mixing, we treat this mixed influent by TAO system, which operated in thermophilic and oxidation condition, and we treat for 3 days. Here we can see the actual TAO system had been used in this study. For electrocoagulation process, we used a 5,000 milliliters volume of glass beaker as a reactor vessel, and we use iron and aluminium as electrode. We use DC power supply with capability of 30 volt and 30 ampere. we run this operation for 180 minutes and we change the polarities after every 30 minutes. So this is the outcome of our study. In figure 3 we see the dark brown color of material here. This is the tau effluent which we did the electrocoagulation, and here we see the changes of the liquid. So here what happened was, after 30 minutes the color changed and the particles from liquid and solid start separated. And in this picture we can see some flock, some clear water, and in the last picture we clearly see the flock, sediment, and the separated liquid. So in figure 4, here we can see the condition of mixed influent, which was brown, and after the tau treatment the tau influent, this is also looks brown, but when we apply the electrocoagulation, then after the process we get this golden color liquid, liquid which is very highly nutriented. So the main feature of the electrocoagulation I want to discuss here or show is the current density. In this study the average current density was 623 milliampere per centimeter square, and we use this equation to analyze the removal efficiency of the characteristics. So let's check the characteristics evaluation of the treatment. In the beginning I will talk about the physical parameters. So in the case of conductivity, we see the mixed manure or the mixed influent had 9.2 millisiemens per centimeter of conductivity, which reduced 7%, which means the tau had the 7% of reduction efficiency of conductivity. And after performing the electrocoagulation, we saw the conductivity reduced to 6.4, which means the electrocoagulation had 29% of removal efficiency on tau influent, and in total the electrocoagulation had 34% of removal efficiency on mixed influent for conductivity. In the case of pH, it's kind of different, like opposite picture. So here we can see the mixed influent had 8.7 level of pH, which reduced after tau treatment to 8.6. But when we operate the electrocoagulation for long time, like 180 minutes, the pH increased to 10.6, which means the total increase of pH was 22% for mixed influent. So in the case of nutrients, we see the Tn was 1481.8 milligram, and after tau treatment it became 1510.8 milligram, which means tau increased the level of Tn by 2%. And when we operate the electrocoagulation, it reduced 25%, or the removal efficiency of Tn was 25% by electrocoagulation for tau influent. However, the total reduction or total removal efficiency of Tn was 27% by electrocoagulation on mixed influent. In the case of TP, we see the mixed influent had 140.9 milligram, and TAO had the removal efficiency of 59% for TP, and the electric coagulation had total 90% removal efficiency for TP on mixed influent. In the case of K or TK, the initial or mixed influent had 916.1 milligram, and after tau treatment it increased to 958.3 milligram, which means the increasing of TK was 5%. But after performing electric coagulation, we see the reduction of TK to 829. So for tau influence, the electric coagulation had 13% of removal efficiency for TK. But in total, the increase of TK was 5% by electric coagulation. So in the case of ammonium nitrogen, we see the mixed influent had 791.4 initially, which was reduced 19% by TAO system, and electric coagulation had total 34% reduction efficiency for NH4N. And for NO3, we see the TAO system increased 84% of NO3 from the mixed influent, but the electric coagulation reduced 29% of NO3 from the tau influent. But when we check the total, the final reduction of NO3 was 90, not reduction, the increasing was the 19% by the electric coagulation for mixed influent. So now we will see the changes of heavy metals according to LFQC, liquid fertilizer germination index. The chromium, copper, nickel, and zinc categorized as a hazardous heavy metal. So in the case of chromium, we see the initial level of chromium was 1.05 milligram in mixed influent, but it was increased to 1.4 after tau operation, which means the increasing was 34%. However, when we applied the electric coagulation in tau influent, it reduced to 28% for tau influent, and finally, in total, 4% reduction happened for mixed influent. And in the case of copper, nickel, and zinc, when we apply the electric coagulation, we see there was no detection of these three heavy metal components. So therefore, we can say the reduction efficiency was 100% by electric coagulation. So if we check the minerals, we can see how they change in these three stages of our experiment. For sodium, the tau treatment increased 11% of sodium from 567.5 milligram to 627.5 milligram. However, the electric coagulation reduced this level to 12%, which means the electric coagulated sample had 553.7 milligram of sodium. In total, the reduction efficiency of sodium by electric coagulation was 2%. In the case of calcium, we see the total removal efficiency by electric coagulation was 78% from mixed manure influent, and same thing happened for the sulfate here. So let's see, we can see here the total removal efficiency by electric coagulation was 70% from mixed influent, and magnesium was not detected because when we operate the electric coagulation on tau influent, the machine did not detect the presence of magnesium. So we can say the removal of magnesium was 100%. In the case of iron, we can see tau had 26% of removal efficiency, and electric coagulation had 54% removal efficiency on tau effluent. However, the total removal efficiency was 66% by electric coagulation for iron in mixed influent. In the case of COD, tau had the 33% of removal efficiency. However, the electric coagulation had 84% removal efficiency on tau effluent, and in total the removal efficiency was 89% by electric coagulation. And in the case of maturity, we did the LFGI, which means the liquid fertilizer germination index, to check the maturity level of the samples. So here we find that the mixed influent had only 62% of germination, and tau treated sample had 81% of germination, and the electric coagulated sample had 133% of germination, which means the tau had 31% increasing of maturity or germination on mixed influent, and electric coagulation had 115% of increasing of germination on mixed influent. So in conclusion, we can say the electric coagulation process can more purify the tau influent, and for electric coagulation, iron and aluminum electrode are very suitable option for reduction of conductivity, TP, and the heavy metals, as well as calcium, sulfate, and iron. Whereas the tau treatment increases the level of NO3, TK, chromium, nickel, and calcium, as well as the sulfate. The final removal of COD by electric coagulation was 89%, which proves the purification efficiency of electric coagulation. And the germination of electric coagulated sample was 133%, which means electric coagulation process can more mature the tau influent. So as we already know that the TAO system reduces the harmful compounds of liquid manure and purify the manure by its thermophilic aeration process, and the controlled electric coagulation can regulate the balance between harmful and useful component of tau influent. So in the end, I want to say the electric coagulation and TAO system have the possibility of co-treatment of liquid manure to produce high quality organic liquid fertilizer. This is the end of my presentation. Thank you all. And if you have any comments or question, you can ask that in comment section. Thank you.